1 is on solving systems of equation by graphing. So basically we're just going to graph two lines on the same grid, and we're going to find the point that they both have in common. Okay, easy enough? Pretty easy for a Monday. All right, so a system of equations is a set of two or more equations containing two or more variables. So if you have an equation that has two variables, you need at least two equations in order to solve it. If you have a system of three variables, x, y, and z, then you need three equations to solve it. We'll do something like that later as well. So a linear system is a system that has only like y equals mx plus b form. You guys with me? Rodrigo back there? All right, so the first thing that we're going to do is we're going to check to see if points work in the system or if they don't. So we're going to see if 1 comma negative 2 is an element of the solution set of this linear equation, so y equals mx plus b form. So we're going to plug in for x and for y. So I'm going to have negative 2, and I want to see if that's equal to 3 times 1 minus 1. So I usually put like a little question mark over it because I'm not sure if they're equal. And in this case, they're not. So we get negative 2 is equal to 2, and that doesn't work, right? So that means that no, that is not a point that's on that line, basically. Okay, it wouldn't be like one of the t-table values. All right, so if we tried in the other one, we have negative 2. We want to see if that's equal to 3 times 1 minus 5. That one does work. We have 3 minus 5, which is negative 2. So yes, this is a point on the line. So if something is going to be the solution of a system is more than one equation, and then it has to work in every single line. Okay, so it says use substitution to determine if this is an element of the solution set for the system of equations. So we're going to have our x plus y equals 0, and we're going to have our 7y minus 14x equals 42. And we're going to see if this is a solution in both of them. So we're going to plug in negative 2 for x and 2 for y. And when we do get 0 equals 0. And then when I plug in 2 for y and negative 2 for x, so be careful when you plug them in, we get 14 plus 28, and that does equal 42. So that works as well. So what does that mean? That means that negative 2 comma 2 is on both of those lines. Okay, so it's probably like a situation where we have two lines intersecting, and we have the point negative 2 comma 2 where they're intersecting. Okay, so that's what we're going to be talking about today. Now there is another case that it could have been. It could be where the two lines are exactly the same line. So if the two lines are right on top of each other, then they actually have an infinite number of points that are in common to them. Does that make sense? Okay, so we're going to talk about those as well. All right, so number 3, it says use a graph to solve the system, and this is what your homework looks like. It's basically just all this. So we have 2x minus 3y equals 3, and we have y plus 2 equals x. So the first one, this 2x minus 3y equals 3, I could do the x-intercept, y-intercept method, but I don't really want to. Do you guys see why this one's not as nice to do the x-intercept, y-intercept method on? Yeah, so see why it's like, if I cover up the y, I'd have 2x equals 3. I get 1.5, which is fine. Like it would be like right here at 1.5. But I don't know. I don't really like having decimals. I like it to be very clear on my grid. So I'm going to go ahead and I'm going to solve for y. So if you solve for y, we're going to subtract the 2x over. And we're going to divide by negative 3. So we get y equals positive 2/3 x and then minus 1. Did I go too fast? So the equation y equals 2/3 x minus 1 is in the form y equals mx plus b. So our slope is 2/3 and our y-intercept is negative 1. So a lot of people, well not a lot of people, a couple people on the test, when they were graphing their lines, oh, it was so sad. They were putting their x-intercept, not their y-intercept. Okay, not an x-intercept. Start at the y-intercept. Right. So then our slope is 2/3. So we have up 2, right, 1, 2, 3. Up 2, right, 1, 2, 3. And I usually do it quite a few times. So I would go down 2, left 1, 2, 3. Down 2, left 1, 2, 3. So just kind of fill that whole space with dots because that really helps in this section to have those dots. You'll see why. All right, and then take your ruler and we'll very nicely draw this in. So that's the first line. You guys can use the side of your phone too if you guys need to. All right, now the other line, this y plus 2 equals x. So maybe I'll do that one in blue. So if you have y plus 2 is equal to x and you're solving for y, it's actually pretty easy to get y by itself, right? So we're going to subtract the 2 over. So we're going to have x minus 2. So we're going to go down to negative 2, and now our slope is 1. So the slope is up 1, right 1, up 1, right 1, right? 1 is 1 over 1. So up 1, right 1, up 1, right 1, up 1, right 1. Do you guys see why it's nice that we drew those points in? Because we can tell where it's overlapping. It gets very close there for a second. Okay, and then we draw it in. So our solution was right there at that corner. So what is that point? What's the x, what's the y, Greta?
3, 1.
Yep, it's 3, 1. That is our solution. So make sure you write that as your answer, 3, 1. That means x is equal to 3, y is equal to 1. And if you get stuck, you can always check. So some people finish the test so early. They finished it so early and they had all this time, and then they made little tiny errors. So if I was checking 3, 1, I would just go back to my original, right, and plug in 3 and 1. If I plug in 3 to the top one for x, I get 6. 1 is 3 times 1, 3. That does equal 3, so that works there. And if I plug in 3, 1 to the last one, I get 1 plus 2 equals 3. That works as well. So you can always quickly check these. All right, I try to make them very nice, but sometimes they aren't nice. Sometimes the answer is like 1.5, 3.75. Right? Then it's hard to use this method. This is why we learn other methods besides graphing. Wouldn't that take forever to graph every single thing? All right, so this first one. So I have y plus 2 equals 3x. So if I'm solving for y, I get y equals 3x minus 2. So your y-intercept is negative 2, and your slope is 3. So go up 3, right 1. So if you want to write that as 3 over 1, that's what we're saying. Up 3, right 1. Up 3, right 1, and so on. So keep doing that all the way. And it was a positive slope, that's why it goes upwards in the end, like when I read it like a book, left to right. Kind of missed mine. I'll draw it a little bit better. It's hard on the screen sometimes because it's not calibrated perfectly. I still missed it. Whatever. All right, and then this other one. So if you're graphing its line, it's going to be y equals, I'm going to subtract my x over, and I'm going to subtract the 6 over. So it's going to be y equals negative x minus 6. Do you guys all see that? So go down to negative 6, and then your slope is negative 1. So down 1, right 1, down 1, right 1. Or you could go up 1, left 1. Just make sure as you read it like a book from left to right, it is going downwards. All right, so can you guys see the point? What's our answer? Yeah, negative 1, not negative 6, close.
5.
Negative 5, yep. So negative 1, negative 5, yep. So that is the solution to the system. That's what we said. Easy enough? You got this? All right, now clearly there's always something weird that happens in Algebra 2, right? So that's kind of the Algebra 1 stuff. You would graph 2 and you'd find where they intersect. So we could have some weird situations. So I don't know if you guys did this in Algebra 1. I usually do when I teach Algebra 1. You could have lines that are parallel. All right, what if your lines are parallel? How many solutions are there? How many places? Right, there's no solution, right? Or you could have lines that are exactly the same line. And that's infinitely many solutions, right? So you can have weird situations. So that's what it says down at the bottom. So you kind of need to get used to using math words. I was tutoring someone this weekend, and she couldn't start her homework because her teacher had said, graph on the Cartesian coordinate plane. And she was like, what's the Cartesian coordinate plane? It's this. That's all it is. They just used fancy words, and then she got confused and didn't know how to start her homework. And then once I was like, oh, it's just a regular grid, she was like, oh, I totally know how to do all of this homework. Whoops. So sometimes there's weird math words, and we need to know those weird math words. So here they are. Consistent and inconsistent. All right, so consistent is something that has a solution. Inconsistent is something like when you plug a number in, and then it doesn't work, like if you get 0 equals 7, that's inconsistent, right? That is a no solution one. So consistent is at least one solution, inconsistent is no solution. And if you have a consistent system, it breaks into two things, dependent and independent. So dependent means it depends on what your x is, and I'll show you what I mean by that. That's an infinitely many solutions. And independent means that it's just a single answer. So independent is exactly one solution. So we're going to use that on these next ones. So it says, say whether the equations are independent or dependent, and if the solutions are consistent or inconsistent. So the ones we've done so far were consistent and independent, both of those. It was one single solution. All right, so this first one, we could do the x-intercept, y-intercept method for this. That would work. So if I was doing that, my x-intercept, if I plug in 0 for y, what do I get for x? So cover up the y. X equals 4, right? So I'd have 4 comma 0. And my y-intercept, if I plug in 0 for x, yeah, I get negative 4. Negative y equals 4. I get negative 4. Do you guys remember that method? The only thing I don't like about this method is I don't draw in a whole bunch of points. I just have to connect those two points right there. Okay, which can be kind of tricky because you really have to have a good ruler. You got to be very careful. Okay, so if we're connecting these points, which is hard on this, we have that. So that's the first one. So the second one I could also do with my x-intercept, y-intercept method, but you guys see how this one's a little gross? Because if you cover up the y, what do you get for x? Cover up the y? 2.5, right? 5 over 2. Right, that's not as nice. So let's go ahead and solve this one for y. So if I solve for y, I get y equals negative 2x plus 5. So I'm going to go up to 5. 1, 2, 3, 4, 5. And my slope is negative 2, so negative 2 over 1. Got it? So you're going to go down 2, right 1. Down 2, right 1, and so on. Did I hit it? Yeah, I did hit that. And that's the second line. All right, so it's kind of hard to see. Mine doesn't look very good. I could draw that a little bit better. It's actually intersecting right there on that corner point. Can you guys tell what that corner point is? Yours probably looks nicer than mine. I think it's 3 comma negative 1. Do you guys agree? All right, so this is what makes it a little bit hard with the graphing because you really do have to have like a perfect graph. Yeah, Rodrigo?
So why do you switch it?
Why do I switch what?
No, I'm saying like why? You switch it to the other side of the...
I don't know what you're saying.
Right.
Why did I switch
Never
one?
mind.
That's okay. I'm just confused on what you're saying. Do you guys understand what you're saying? Like the slope is up. Is that what you're talking about? Slope goes up and then over?
No, like, never mind. I got it.
So this is 3 comma negative 1. Over 3 and then down 1. Okay, your slope should be negative, so it should be going downwards, yeah. Is that what you're asking, Rodrigo? So your slope goes downwards?
Thomas,
Oh, you got it.
Thomas! Oh, okay, I see how it is.
Caleb.
Okay.
All right,
Who's
so
Thomas?
Caleb figured it out. All right, so this one. So we can solve for y for each of them, or you could do the x-intercept, y-intercept. It doesn't matter. So let's say we go ahead and solve for y. So if we solve for y, I'm going to subtract my 2x over. So negative 4y equals negative 2x plus 8. And then I'm going to divide by negative 4. So I end up getting y equals 1/2 x minus 2. So 1/2 x minus 2, the y-intercept is negative 2, so go down to negative 2. And then your slope is up 1 over 2. Up 1 over 2. Up 1 over 2. Right, it's a positive slope, so we're going upwards. You could also go down 1 and left 2 if you want. Down 1, left 2. So just do quite a few points. It helps when you're graphing too. Okay, and then this other line, if I solve for y, I'm just going to divide that 2 over. So I'm going to get y equals 1/2 x plus 7 over 2. Ooh, that's a little bit harder, right? 7 over 2. Yeah, what do you think, Caleb? What's the y-intercept? Where do I go? Nope. It's 3.5, right? This is the same as 3.5. 3.5 or 3.5. So I'm going to go up to 3.5. You're thinking slope, yeah. And it's a little bit hard because it's kind of there in the middle. So you're up a little bit more than 3.5. So now when I graph it, I'm going to have to go like between my grid lines. So I'm going to go up 1, and when I go up 1, I'm going up to 4.5, and then over 2. And that's my next point. You guys see that? So be really careful. Yeah, so some of you guys are realizing, oh wait, they're parallel. And that is exactly right. How do I know for sure that they are parallel? What's special? Ah, same slope. Good. You guys are good. My first period was sleepy today. They were not on it. They were like, what? How do you know they're parallel? Ah, I forgot to talk about that on the last one, didn't I? All right, so they have the same slope, so these are parallel. Oops. So what this means is that these are never going to intersect. They're going to keep going up and over at the same rate. So that means that this is going to be no solution. All right, so let's talk about independent, dependent, and so on. So the very first one, number 1. Was there a solution? Yes, there was a solution. So that means that it's consistent. So there is a solution, so it's consistent. Once you get consistent, consistent breaks into 2 subcategories. So our subcategories are dependent and independent. Dependent is when they have infinitely many solutions. Independent is when there's one solution. All right, independent means one solution, so this one is independent. Because they do, yeah, they just cross exactly one time, right? You can't like loop it back around and cross more than once, yeah. So consistent and independent. Now this one did not have a solution. So all we say is that it is inconsistent. And then we're done. Because inconsistent does not break into independent, dependent. That was only for consistent, okay? So just inconsistent. All right, so number 3. What do you think? It probably is infinitely many. So what does that mean? It means it's the same line. So let's see. So this one, let's solve. So I'm going to subtract my 4x over and divide by -2. So we get y equals 2x plus 3. So you're going to go up to 3. And your slope is 2 over 1, right? So you're going to go up 2, right 1, up 2, right 1, up 2, right 1. And what do you notice? What was the first equation that I skipped? I should have graphed it first. It's exactly the same. Funny how that is, right? Caleb knew already. He guessed. So the other equation, which I'll, oops, I totally moved it, didn't I? Thomas. Is that his new nickname? All right, if I graph that one in another color, it's exactly the same line. So they overlap. So every single point on that line is a solution, okay? So we call this, so we say infinitely many solutions. So someone in the other class was saying, well, can't you just say all real numbers? And you actually can't. The correct thing would be infinitely many solutions. So here's why you can't say all real numbers. Every point on this grid does not work, right? What if I picked this point way over here, like 5, 0? Does 5, 0, is that on that line? No, 5, so you can't be like, oh, every single point in the whole grid works. That's not how it works, right? So we actually should say there are infinitely many answers, but we don't know exactly what those answers are. So the question is, how do we write those answers? And you guys don't have to do this on your homework, but let me show you. This is what you would do in pre-calc and so on. If you were writing the solutions, we use a t for the x. And we say, oh, well, it's going to be t, comma, 2t plus 3. Do you guys see where I'm getting 2t plus 3? Look at your first equation, y equals 2x plus 3. So if you plug in a t value for x, do you guys see it, 2t plus 3? Rodrigo, are you with me? So if you plug in a t. So here's what's happening. You what? Yeah, let's go ahead and write it down so you guys can see why we call it dependent. Gives an infinite number of points. So let's think about it. What if you plug in 0 for t? You get 0, comma, what? Plug in 0. 0, comma, 0 plus 3 is 3. What if I plug in 1 for t? What do I get? 1, comma, close. 5. What if I plug in 2 for t? What do I get? 7. These are all points that are on that line. Do you guys see why it's called dependent now? It depends on what t is, on what your x, what your y is, right? So it's infinitely many solutions, and we would say that this is consistent because there is an answer. there's more than one answer, and it's dependent. And the reason it's dependent is because it depends on the value for t that you're plugging in. All right, so the last one, it says, or the last little box, it says, if the lines are different and they intersect, the equations are called consistent, and the system is independent, yes. I think I actually have those flipped, but that's fine. I think it should be independent and then consistent. I think we say consistent system, so well, I'll erase it, but you don't have to, it's fine. And then if the lines are different in parallel, the system is inconsistent. Okay, that would be like when you plug in the points to check, you don't get something that's true. Any point that you would possibly plug in would not be true. All right, we do not say that it's dependent or independent. And that would be when there's no solution. And then the last little bit says if the lines coincide, so they're one directly on top of the other, the equations are called dependent. And the system is inconsistent. Or not inconsistent, what am I talking about? Consistent. Okay, does that make sense? Can you guys all memorize those math words?
Yes.
I think you can too.
I'm very good at memorizing.
All right, so your homework is very easy. There's only 9 questions, and some people in the first period class finished before they even left here.